Probabilities of binomial experiments. Our objective, we want to compute probabilities of binomial experiments using the formula. Okay, a couple things we want to remember as we get started here. A random variable is a binomial if four conditions are met. We saw this in a previous video. We have to meet four criteria. Number one, a fixed number of trials. Number two, each trial has two possible outcomes, success or failure. Number three, the probability of success is the same for each trial. And number four, the trials are independent. And from back with our probability lessons, we've talked about combinations. The number of combinations of n distinct objects, taken r at a time is given by this formula. We got our combinations with a sub n on the left and a sub r on the right. So the combination for r objects taken from n objects, taken r at a time, is n factorial divided by r factorial times the difference n minus r factorial. Okay, we're just gonna give you the formula and we're gonna make use of it. I'm not even sure I know how to derive the formula. The binomial probability distribution function. The probability of obtaining x successes in n independent trials of a binomial experiment, must be binomial, is given by the probability of x we're going to use the combinations formula from right up here. So this piece is here times p to the x times 1 minus p raised to the n minus x. So we've got three pieces. We've got a piece here, we've got a piece here, and we've got a piece here that we're multiplying together, where x is equal to 0, 1, 2, up to n, and p is the probability of success. Okay, let's do some examples of applying this formula. We're also going to apply it and take a look at doing it with Statcrunch. So we'll kind of do some, by hand, and we'll also take a look at letting Statcrunch do this for us. According to the CTIA, who the CTIA is, I don't know. 72% of all adult Americans would rather give up chocolate than give up their cell phones. I'm not sure where I fall there. I love chocolate, but like most of us, I make a lot of use of my cell phone, so I'm not sure what I would do with this one. But they say that 72% say, I'll give up my chocolate, I want my cell phone. In a random sample of 10 adult Americans, what is the probability that? Letter A, exactly 8 would rather give up chocolate. We'll do this one algebraically. So what do we know? 72% is our probability of success, success being given up chocolate. So this is P. N is the number of trials, number of samples. So here's our N is 10. Okay, and I think we want 8. So this is going to be our X. We want to have exactly 8. Okay, so letter A, we'll do this one by hand, and we'll also do it in Statcrunch. So the probability that 8 say they will give up chocolate. Okay, well we got to do a combination formula. So we'll do, and our N is 10, so we'll do our C with 10. We want 8. We want to have 8 out of the 10 give up chocolate. So that's our first part. And then we're going to multiply that. So I'll tell you what, I'll put this in parentheses just to kind of highlight it. That's our first piece. The combination formula, 8 out of 10. Second piece is this probability raised to the x power. So this is going to be 0.72. That's the probability of success raised to the 8th power, because that's how many we're looking for. And then our third piece is going to be 1 minus the probability of success. So 1 minus 0.72, raised to the n minus x. Well, our n is 10, and our x is here again. It is 8. So there is the math we have to do. Our calculator will do this for us, or if you want to do that all by hand, if you want to go back and you can do that first part, here it is. Okay. All right, or a calculator can do it for you. Then you've got to do 0.7, multiply this times 0.72 to the 8, and then multiply that times 1 minus 0.72 to the, in this case, second power, because 10 minus 8 is 2. You do all that, and the probability that exactly 8 say they'll give up chocolate is 0.2548, about 25%, I guess. Okay, so a 0.258 is the probability. What does that mean? Okay, let's write down what this is all about. So we're going to do in 100 trials. Probability is all about out of 100, right? You're doing percents. Using 100 lets us speak to it, because probability, we know that the probability when we talk about things, it's easier to talk about it as a percent, which means we're dealing with something we're going to do 100 times. 100 trials, in other words, so i.e., survey 10 adults 100 times. Okay, I'll write the word times because that'll be clearer than putting an X down. Okay, in 100 trials, okay, we expect, probability is just about, what we think was going to happen. About 25 trials. Right? 0.25, but we did 100, so times 100, about 25 trials to result in exactly 8 adults who would rather give up chocolate than their cell phone. Okay, that's what it's telling us. Probability of 0.2548. Okay, probability as a percent means we've done something 100 times, and we expect that about 25 times, 0.25 out of 100 trials, we're going to have eight adults, exactly 8, who will rather give up chocolate than their cell phones. Okay, let's take a look and get the same answer using Statcrunch. Although we said here algebraically, let's take a look at Statcrunch to confirm. Okay, Statcrunch. I'm going to simply, there's no data set here. We just want to use the Statcrunch calculator. So I'm going to go into Open Statcrunch here, and I'm going to open up the Statcrunch calculator. Okay, there we go. I think, let me get it to hopefully focus. Maybe, come on. Maybe not. We'll see. See if we can get better. So we go to Stat. Okay, we want to go to Calculators, and we're going to calculate a binomial. Okay, and here is our what pops up. If we come down to the bottom a little bit, is that n is 10 and the default, p is 0.5, probability of success is 50% in the default, and this is the distribution you get right here. Well, we want to make a change to this. We want to leave n alone, and we're dealing with 10, so we can leave that. But our probability of saying they'll give up chocolate, our probability of success, which means they'll give up chocolate, is 0.72. So we're going to change this to 0.72. So there we go. And then we want to change this symbol not to less than or equal to, but to equal to only. It's right there. And we want to equal to 8. So I'm going to change the 5 to an 8, and I'm going to press compute. And you can see down here, there's the red line for 8. And the red line comes across here at right about 0.25. And if you look down at the bottom here, you can see there is 0.254, and I rounded to the 10 thousandths. 0.2548 is right there rounded. So that's making use of the calculator in Statcrunch to do it for us. Let's do some more examples. I've got 4 here. I need to go to another piece of paper. I need some more space. And what I want to do on this next piece of paper is I first want to write that formula on top. So let's remind ourselves, probability of x is equal to the combinations formula, which is, NCX here, times the p to the x power times 1 minus p to the n minus x power. So I just copied that formula so that it's on this piece of paper and we can make use of it and see it right directly in front of us as opposed to going back and forth. The second part, letter B, said probability that we have fewer than 3. So probability that x is less than 3. That's fewer than 3. It doesn't say or equal to, or it doesn't say 3 or less. It says fewer than 3. Well, fewer than 3 is going to be 2, 1, 0. Okay, well, that's the same thing as I just mentioned. Probability of 0 plus probability of 1 plus probability of 2. That's 2, 1, 0. Okay? Well, each of these needs to go into this formula. So this is equal to, let's start with 0. We get our C to tell us we're going to do a combination. And n is 10. We want to get 0 out of 10. We know that our probability is 0.72. We're going to raise that to the x, which is 0, because we're dealing with a 0 one, times 1 minus 0.72 raised to the 10 minus 0. That's the first one. This one is here. Plus this one. Okay, C, 10, choose 1, 0.72 to the first power, 1 minus 0.72 to the 10 minus 1. That is this one. Plus, see where I'm going with this. Got to do this one. C10 choose 2 times 0.72 to the second power times 1 minus 0.72 to the 10 minus 2 power, which is 8. And I can't underline this, but this piece goes to that one. So we need to do these 3 things separately. Into a calculator we go, because it said algebraically, and out comes probability is 0.00096. Okay, the probability in this situation of fewer than 3 adults saying they would rather give up chocolate is pretty darn small. Okay, if we do this 100 times, it's even less than 1. It's fair piece less than 1, actually. So that's it there. I will not do, well, I'll do this one in Statcrunch because it's already kind of lined up here for me. I'm going to use the exact same, I can do this quickly. I'm going to use the exact same diagram I already had opened. Okay, so this is the one we just did. I'm going to go down here and say, well, the number is still 10. The probability of success, giving up chocolate, is still 0.72. But now we want it to be less than, I'll choose that one, less than 3. And I'll press compute. And you can see here, wow, it's not giving us much. Yeah, here's 3, because it's counting 2, 3, 4, 5, 6. And you can see here that it's not even counting 1 or 2 or 0. It's it's this little bitty number above 0. Look at my scale. 0.05 is the Y scale. So it is showing us where that is on the graph. It's right here. But you really got to get in there on my iPad. But the probability And that's what we came up with, 0.00096. Okay, but there's the red. It's showing me in red like it did last time. Here's where you want to be, but there's not a whole lot there that I can show you, I being Statcrunch, of course. Okay, let's take a look at letter C. I think I'm still pretty good with my being straight and on there for you. Letter C, the probability at least 3. Probability at least 3 means we're starting at 3 and going up, and we're including 3, so greater than or equal to 3. Well, if we were to use this method, we would do 3. If we were to use this method, we would do 3, 4, 5, 6, 7, 8, 9, 10. That'd take a while. We could use the complementary method, which is the method that says, I already know less than 3, so greater than or equal to 3 is 1 minus less than 3. Same. And we already know less than 3 is this. So this is 1 minus 0.00096. And that comes out to be 0.0990. So the probability that we're going to have 3 or more people who will give up chocolate as opposed to their cell phone, the probability they would rather give up chocolate than their cell phones, they're very happy to give up chocolate. 99 times out of 100. You're gonna have 3 or more people who are gonna say, yep, I'll give up chocolate, I want my cell phone. Let's take a look at it briefly in Statcrunch because it's already there for us, already set up. And we want to be greater than or equal to 3, so I'll go back and choose that. Whoops, I'll go back and choose that greater than or equal symbol. And I think it already computed it. It did already compute it. Yeah, there's your 0.9990 right there. Notice it uses the red to show us as it turned to red. Down here is black, that little dot, but it's saying, hey, yeah, this is your greater than or equal to 3. 3, 4, 5, 6, 7. This is the part of the graph you're concerned about. 3 or greater. That's part of the graph you're concerned about. Okay, last example, and I'll let you do it with Statcrunch. I'm just going to give you the answers. I'll do it with Statcrunch too. How about that? What is the probability that you have between 5 and 7 inclusive that would rather give up chocolate? So the probability that X is between 5 and 7 inclusive looks like that. It includes 5 and 7. So that means we're dealing with probability of 5, 6, or 7. We could do it this way and do 5, 6, 7. But we're going to use technology because that's a lot easier. And we're going to go into here. And we're already set. And this time we need to, I think I have to, yes, I got to choose between. So I'm going to my between selection. And down here now I can put between 5 and 7. So between 5, and I already have the equals is already included here. 5 to 7, and I'll compute. And how about 0.5280? I'll go 0.5280 as I round there. So the probability that between 5 and 7 adult Americans would rather give up chocolate, inclusive, is I forgot what I've said. 0.5280. So 0.5280. So if we have 100 trials, it looks like in almost 53 of those, we will have 5, 6, or 7 adults who would say they would rather give up chocolate. So there you have it, probabilities of binomial experiments.